Hello everyone. Are you working with LM-generated code in IDEs like Cursor and VS Code, but worried about potential security vulnerabilities? Today, I'm glad to introduce a powerful new product from Virtual AI, VirtueGuard Code. This is an easy-to-install plugin. We just need to install from the marketplace in Cursor or VS Code, and it provides real-time vulnerability scanning for code generated by AI models. It just continuously analyzes your code looking for common security weaknesses like overflow, command injection, and etc. So with this tool, you can catch vulnerabilities early in the development process. It supports commonly used programming languages like C, Python, and Java. Below we will show two demos of this plugin in protecting C and Python code in Cursor. So let's see it in action. Here's a code script of reading and writing the WebP image format in C. It has multiple functions that decode, parse, and composite WebP files. For example, the isWebP function, and readWebP image function, and writeWebP image functions. So now I want the model to generate an individual function called isWebImageLossless. And I have already provided the image implementation details. I'll use the agent mode to generate this function. So when the cursor applies this to us, you see our VirtueGuard code will automatically do the analysis for these individual functions. And now let's see what happens to this function. It says it's vulnerable. Okay, we can see here that in the while loop, when we do offset plus 8, it is potentially an integer overflow because we add offset by 4 may make it as a negative number that will not end the loop and result in buffer overflow. So our model successfully identifies this bug, and what we can do is to identify according to the suggestions. So now let's save the model again. And you can see after we do this, it's not vulnerable anymore. It becomes benign and means this vulnerable is fixed. Here's another example in Python. In this code, we are using Cursor to do auto-completion. And it's about taking and executing user-provided input. You see, when we save the model, VirtueGuard code writes an alarm related to the eval function, as shown in the report. The LLM-generated code uses eval without necessary checks, and this can lead to arbitrary code execution. So VirtueGuard code successfully identify and flag it, as well as providing potential fixing suggestions. Here, VirtueGuard code also flags the main function as vulnerable, although it does not have the eval function, but it actually calls the vulnerable function. So it shows that our model can take function call relations into consideration.